Hi, and welcome to my third video in the Commodore 128 series. This series is being kind of unstructured because some things that should be easy is not so easy, and some things that should take a long time has been really easy to fix. And I also have to do some things out of order just to get some things off my bench. And the 128, it's a bit more than I really can do good filming here on my bench down in my basement. Because this bench is very narrow, I do have the camera set up for more closed view, and I don't have a lot of space to mount the camera so that it can shoot over my shoulder and so on. So this is not optimal, I know. And I also do have a fault with my capturing device for capturing composite video, and that kind of sets me back, and that means that the footage I get from 8-bit stuff is very bad. But I do have a solution for that, I hope. Otherwise I do have to go down to the bunker and get up a Windows XP PC so that I can use my really old capturing device that's only XP compliant. But in this episode we do have to change the focus. This episode is about repairing and fixing the second Commodore 128 DCR, the one that was complete in a box. And this belongs to a fellow Commodore enthusiast that lives close by, and I promised him that I will take a look into this machine now, and I have to make it finished. I probably will keep it here for some more days to be able to do comparisons with this one to make the repairs on Arctic Retro's device more easy. But there is this thing about the Arctic Retro motherboard. There are some, cyclic fault on that. So it's not very easy to do fault finding, and that is something that will take some time. Because actually it behaves somewhat different from time to time, and sometimes I'm able to make it boot a bit, sometimes I don't. So I really have to get a solution for a diagnostic cartridge or some device to make it fundamentally more stable and the same from time to time before I dig more into that. And that might mean that I have to go down to the bunker and get out one other 128 DCR. So this series will be several episodes long, but this time it's about Per Vidar's 128 DCR and making that one great again. So let's just dig in. It's kind of unstructured, as I said. Apologies for that. This is the board from the other C128 DCR, and this one is, I have to change this one. This is a 6526, and this has diagnosed that it spins the drive all the time, and as I mentioned earlier, it came when they was disconnecting a floppy emulator device from this unit, and then this one has got a bit of a spike. So that's fairly easy work, I think. There has been done some rework on this before, or I'm not sure if it's rework or if it's just a manual labor with connecting things together that has been done on this. But you can see some markings here from flux. And there are also some bad solder joints here, but I don't think this is critical for anything. But anyway, this is a 355116 revision 5 board. And the board that I had from Tommy at Arctic Retro is actually a revision 1 board. So they are slightly different. What the difference is, I'm not completely sure. But I'm just going to desolder this one and replace it with a socket. And I'm just freshening up the old solder with some new fresh solder with the leads in, so you have a low melting point. It will make it much easier to use my removal gun afterwards. I do have to hit this with the rework hot air gun afterwards, but there are some holes that I need to fill with solder again and use the gun to remove, because there are some narrow holes on this, and especially with the one with the huge ground planes, it's difficult to desolder. Desoldering ships is a bit hit and miss, but with experience it's kind of lessen the damage on the board. And there is always this you have to weight the different options between each other. Desoldering gun with the desoldering, if that works, that's the best. With the two-sided PCBs, you do have some residue solders left on the top side. There is always some friction there, and if you are trying to break anything loose, you will lift some pads eventually. So it's always about making things as careful as possible, but of course the heat is also loosening the copper traces from the board, so you can't use too much hot air either. So it's kind of a trade-off, and you have to use your experience to see what's best in each case. This might seem a bit brutal, but it's not about accessing force, it's just to use what leverage you have, so that this actually will be lifted once I see it starts getting out of the tracks. So it's all about being careful. And here are no lifted tracks. It actually seems quite good. You do have to use some solder wick for cleanup. It's some hole that's partially closed, and you also need to get a fresh layer of solder on there, and that is very good to use the solder wick to clean this out. And in this case we use a normal double sweep socket, not a machined socket with the round holes. Even though the ship I'm going to put in here, this 6526, is not a new on-shelf part, it's bought as a used part. I could have borrowed this from one of my other machines, but since this is a service repair for another person, it's more just to buy the parts from outside. It's a better policy, I think. And we're just going to solder this in. It's nothing special about this soldering. It's very easy work, very clean, and very easy PCB to solder on. And we just use some alcohol and a cotton swab just to clean up most of the flux from the PCB afterwards. Now we have to do a quick test of the thing. I don't expect it to work straight away. What I expect now is that we should be able to measure out some things on the bus of the serial system of the C64 part and the 128 part. I was not able to do that before, so that's how I know that the 6526 was bad. This is actually some work done some time ago, but I do know that there is more than one fault, but what more that is fault I can't really say until we have tested and seen that this machine actually now works and is not in worse condition with the new 6526 chip. Before I put the power on, I need to put back these room chips that I took out to make a copy of them. I could of course have copied the one on Tommy's machine, but I didn't know that this was working, so I took out these to have working copies if I ever needed them on the Arctic Retro machine. And of course, with not the drive connected, I couldn't hear on the spindle motor and stuff to see, and the seek to see how things are working, but I kind of get the right message here on screen. We get the 128 screen with no ready message, and that is the fault we had before, so this was expected from this. So now let's continue to find out what else is fault on the floppy part of the board. Yeah, and I also try with the keyboard attached here. This is because if the C128 is working as it should and the 6526 is working, you should be able to hit the run, stop, restore and get your prompt back and be able to type something on the keyboard. So that's what I was testing here. Sorry, no footage of that. Yes, and I'm back here with the schematics for the 128 DCR, and this is the second one I'm looking at. This is the one where I changed the 6526 chip, and I'm now able to use other IEC devices on the bus, so I do know that the device actually is working. But to do that, I had to do a small thing, and I will show you what I've done. You see here are all the signals that comes into this computer, and you also have some ups here. You have reset and drive reset and stuff that goes to this chip up here. But what I'm more concerned of is this signal here, because this is normally what keeps the drive spinning, or this one here, it's no clock or no data. So these are all buffered signals. And there are some ways I can just cut the legs of the pins for these chips. And you can see here, this is one chip. This is the U112. You have the U113 and you have the U114. U114 is also used some gates other places here. But this is 7406. That's open collector gate here, and you have the 7414, that is the Schmitt-Trigger inverter gates. So this is what is connecting this drive to the rest of my C128. Otherwise, there are some more common signals. You have, or down here, some clock signals and other stuff. But mostly, this is what connects these two together. And when I remove these two chips, I am disconnecting every signal from the bus. So if that means that I will get a working 128 with these ones connected, it will only be the internal drive that is disabled. And that means I can do the ordinary fault finding process. And the main culprit will then be the CPU. 6522, that is a VIA, same as in the VIC-20, or you will have the EEPROM. And in this case, I would start with the EEPROM. I don't have a new EEPROM, but the EEPROM is already socketed. So on this drive, I'm going to desolder these three chips here, U1113, 1112, and 114, like this. And I'm just going to lift out these gates and then check with the device on the IOC bus and see if that works. If that works, everything is okay with my real 128, and then it's fault finding like this, and this is basically the same as normal 1571 drive, but I've seen somewhere that this has a slightly different ROM version, so I'm going to burn a PROM with this ROM version that is supplied with the DCR, and I'm not totally sure exactly what the number was. Yeah, it's the 318047-02 ROM that is for this. And I will at the same time, for the other C128, the one from Arctic Retro, I will at the same time try to burn a Diag EPROM that should be able to fit inside the U36 available ROM socket on my computer. So that's what I'm going to do next. I'm going to take out my trusted burner, and maybe I do some erasing first of these EPROMs, and then I'm going to just use ordinary UV erasable EPROMs and burn 7428 for the U36 and one, yeah, it's a 27256 for this ROM here actually. So that is my main goal today. Yeah, before I can continue with burning EPROMs, I will give you a quick update here. I have now desoldered these 3 chips, and when I remove them, the cursor comes up straight away and I see 128, and I do have a working 128. And I also did connect my SD to IEC to this bus, and I was able to load the program. Sorry, but I did have to give this away to another guy that needed this to some other fault finding, so I don't have the IEC more for tomorrow. But that was actually what I did. And now I put this back in place, and I'm going to try a different EPROM in here and see what happens. But first I need to use my trusted EPROM UV eraser and erase some chips. And as a start, I will take 128 for this diagram, and I will take one 256. Yeah, this was an ST chip. I wonder if this is China fake. This is at least an old used one, TMS Texas. And I'm just going to place them like so. I have been able to erase them by placing them this way too, and yeah, I can of course do that, and I can erase everyone at the same time if I'm careful. There is this lid that slides over here and connect with this switch to turn on the UV light so you don't damage your eyes. Like so, and I close this, and I give the power supply 12 volt, yeah, like about something like that, and I just connect the red one to this yellow one, and it's this black one like so, and then it just hit start. Yeah, it did start. It was very weak green light in this one, and I do think it stands on for about 10 minutes. And then these hopefully will be erased. Yeah, and to handle EPROMs these days, I use my XG Pro or the TL866 Plus programmer. It's a good all-round device, and even though I have older devices, this one works as a charm, and I just recently upgraded the software to 1263. So it's a really good device. The only problem I have with it is that the SIF socket is not the best. We select here the brand name for this EPROM. It's a TY, and it's a 32K EPROM, aka a 256 as the last digits. And this is a 27256 without any letters in between. But the secret here is just to find something that looks almost like you want and check out the voltages that are to burn. All these modern bigger EPROMs, in my experience, is about 12 to 13 volt programming and about 5.5 to 6.5 volt for the program enable voltage. So if I'm not sure, I try with a low voltage and I work my way upwards. But here it really doesn't matter, because it seems like every one of these EPROMs in this size has the 13 and 12 volt programming. So, and 13, I don't think it will damage anything. The check ID mark actually read out your device's type number. So it won't do anything with the EEPROM if you have the check ID crossed and it's not the right type. Yeah, you have to select the device before you select the file that you want to burn, but then I downloaded this file from simmers.net. That is my go-to source for these kinds of things. And this is a 32K file, and we just select the file and go on from there. Yeah, if the device and the burner are talking to each other, it's just to hit the program, and it will make the programming pass, and it also will make a verify pass. I always make an extra verify pass afterwards, as I have seen some of these older devices, they are just not programming the cells correctly, and if it's a bit low programming voltage and so on, it's very good to do extra verify. Yeah, now we have our finished replacement EEPROM, and it's worth to notice that in the C128, everything except the character ROMs, except the 27 kind of EEPROM thing, that is actually the industry standard, not the 23 or 25 kind of types that was in the older machines. So in the 128 you can use 27 kind of EEPROMs to replace everything but the character ROM. But let's go on to try to install this now in our 128 DCR. As carefully as possible I will try to pry the old EEPROM out of the socket, and this is an original Commodore EEPROM. In the machine from Tommy it was an EEPROM actually, but with a sticker that seemed like something original Commodore. So I don't know what's up with that, but this is an older version of the motherboard, so maybe the first revision was delivered with this EEPROM with the normal UV erasable window, and nothing was masked burned like this yet. I covered the window with a sticker just to keep the UV light out. I don't think it will be a problem anywhere now on the bottom of the drive, but better to be safe than sorry. And I don't know what the shelf life actually are on the UV erasable PROMs. I've heard someone say that they will erase themselves anyway after some years, but I do have a lot of these that is 40 years old. So this now appears to be working, so I just have to put everything back together and just call it test on this one. So when I say put back together, this was a complete 128, so I also have the power supply for this one. And I might consider, when I first took this apart, I did wonder if there has been a leak on some of the caps here. But I do think this is glue that actually has been on here. And the power supply, it does seem okay, so I have not bothered to do anything with this so far. Yeah, we got as far as to put on a new ROM for the drive, and at least it seems to be working as it should. These ones are put in sockets. I will see if I can get them to stick down in the socket, or if I will have to change these. I see with new ones to have them stick really to the sockets, because these legs was kind of cut off. The next thing I'm going to do, I'm going to tie this all together, but before I do that, this is, as far as we know, a fully working 128, and it's not powered on just now, but I want to explore and see if I can get a diagnostic tool, or a diagnostic tool inserted as kind of a BIOS and not as a cartridge into the socket to work and actually have the 128 boot into this before I put this all together. And I might also keep this machine for some more days and not give it back to Per Vidar straight away, as it would be good to have something to compare against when I do more work on Tommy's machine. We just have to see how long time this really takes. And the IC we prepared yesterday, these are the 128s, and I do wonder if these are probably China goods, and these probably are remarked something. I do seem to remember that I couldn't get them to work off the ID on the EEPROM, but that is an easy fix. And I have used these kinds before, so I do think we will get it to work. And this is an ST device, and it's 2700 C128. ST, this one. They don't have a C128 in here. Of these. Yeah, I'm just going to find something that looks alike and see what voltages we are dealing with here. 27C, here you are starting to get this one. And we need a 128 part to be having the right. This is not the C version, but we see what we got here when I put select. It's 12 volt, 5.5 volt right. This is the verify, of course, 5 volt. And we have the check ID here marked off. And I'm going to go to the device. I'm going to have here blank check. And the device is blank. And I'm going to load the file. This is the latest revision of this diag. I also have this one. It's certainly different. Should take some different nest and so on, but this is the one I'm going to try, like so. And if I go to device here and program, yeah, see what it does. It's verifying. I'm going to take another verify to check. It's verified just fine. So now we have a 128 that we can use here. Just let's try to plug it in and see what we got. It's going to make the legs a bit smaller. This is a Commodore socket, but it's actually a double sweep one, so it's kind of high quality, or at least good enough. And there we have this plugged in, and I just power on and see what happens. I have connected here, and this should be free. This just puts into some rubbish now on the normal wig screen. So not a good attempt. So I'm going to try to make the other prom and see what happens there. There might be some chip select or some address line trouble on this, because this is 128, and I saw some readings on the web that this actually should be able to fit 256 32K EEPROM, but this is 128. And actually we got the file we got here. The file was actually 8 kilobits. So I should really copy this in 2 times on this EEPROM to make sure that it's selected right. Yeah, I have to do that and take the other chip. And yeah, I'm going just to put this back in the eraser and have this erased again. Yeah, this is turned off. The 8K file should really be for a 2764, but I don't know if the addressing and chip select scheme would fit that without some rerouting of wires. But I do think the safest bet is to use this 128 and just copy the same file twice into ROM. Yes, let's once and for all settle this. What kind of socket is U36 and what kind of chip does it support? As a matter of fact, it supports all of these chips, and I will tell you why. You can first see that the address lines that are connected to this are A0 to A14. A15 is just my note here. So the chip that supports all the address line up to A14 is the 27256 or 23256, whatever they have here. But you can see what kind of connections they have and check that the signals are on the right pins. You can take a quick check and see that 20 and 20 is the chip select and output enable, and they are in the right place. You have the VCC in the right place. You have the VSS, that is 14, you have in the right place. So everything here seems to be on the right position for a 27256. But what will happen when you connect 2728? Yeah, what will happen is this. If I take 128 and put it on top here, you can see that everything on this side here, it works just fine. But when it comes to this side here, you do have, where you have pin 14 here, you have the programming pin on the 128 chip. So if I take these apart again, so you see it really doesn't matter because this programming is not used anyway if I plug in 128. So it's an input and the A14 will just be ignored. But if it's trying to access the high part or the low part, it really doesn't matter. A13 is the uppermost address line that is selected. So that means that the 128 will be selected and it will be a mirror when you are trying to put a 14 high and use the uppermost address bit on the 26. And you will see the same here on the 2764. Everything is the same over on the left side, but on the other side you have where the A13 is, it's not connected. So it will just ignore both A13 and A14 and you will only have the lowest address space as a real memory space and the other will be mirrors, whatever these are. And then that means that you will have 4 mirrors with a 2764 because you have 2 bit. That doesn't matter in this. And with a 512K, what will happen then? Really nothing, because the difference between an 256 and a 512 is that pin 1 is actually used. And pin 1 on a normal EEPROM is V programming. And V programming, as we see on the socket over here, V programming is stuck to 5 volt. So if you put in a 27512, you will not get a mirror anywhere, but you will not be able to use the lowest of this because address line 15 will always be high. So the situation where A15 is low and you have the first 32K will never come to play. So hope this clarified a bit, and to make matters much worse, this does not apply to the 28 series of PROMs. The 28 series does have some slightly difference in pins, and the 28 series is of course the electrical erasable in most producers' datasheets. So this is for the 27 series of EEPROMs. That is industry standard, and this is what gets. So the socket on U36 on 128 supports all these kinds of EEPROMs. You will have 4 mirrors, 2 mirrors, and 0 mirrors, and you will only use half the chip. So it really doesn't matter, but you need to take into account that you will have mirrors in the memory if you put in the wrong chip. So that's it for mansplaining this thing. Yes, now let's try again, this time with the 16K version of this file, like so. I try to power on, and actually nothing seems to happen. It boots into a locked 128 screen. And is this possible? It should have given exactly the same result as before, if not the P inverted signal on pin 27 has anything to do. But according to the truth table of the 2728, it does not matter at all. So we should have been giving the same result as last time. But I will give this one more try, but I will try this more with my regular 128 instead. So I do wonder if we are going to try the other software that should be adapted for this EEPROM socket. Yeah, we can just as well try that before we give up and start to check into a cartridge version of this. Yeah, what we now have tried is the 588121 bin version of this cartridge that should be adapted for the internal socket. But we have one more version left, and that's the 78901018 version of this. And there are some more diagnostic chips also for the 128, but we are going to give this one a go. We are just putting in a new EPROM and burning that with this software now, and we will check how this goes. This is kind of interesting because this had the same trash screen as the first one. That's the first time I plugged in just this device, and the other had another lockup screen, but it's just appearing to be locked up. So I'm going to do a bit more search and see if I can find some other rooms that will fit internally into this. But I do think what I'm going to do now is finish up this machine here so that I can get one machine off my list. So I will just start to reassemble this one and maybe do a test with the drive afterwards. So I'm just going to tidy up a bit here. I still have these EPROMs standing on deleting, and I'm going to take this one too out of here and just delete it again and make it so that we can give it another go. Most of what I found about the Diagnostic and the C128 I found on this blog worldofjani.com page. And here is listed the one we tried first now, the 588121 I think it's called. And this one is the assembly kit. There are some different names here. I don't have this kit for the 128, but I do have the harness for the 64, and there are some differences. And this is the other room that was adapted for internal use. You can see here that it's internal, but it's standing that it's U36, so this should be the one. And you also have another diag that's also in 2 revisions, and you have also something that's called the DCR integral diag. I don't know if that means that it's supposed to be used in the cartridge slot or not. I'm not sure, but there is lots and lots of things left to try, and I also have this diagnostic here that has a totally other version number. And then there are some more 64 tests. So we actually have a lot of more diagnostic tools we can use for the 128, and I'm going to check them out, I think. But I'm going to leave them be here for now and check them in my regular 128 and in Arctic Retro DCR mainboard. Of course, my small bench will not be the best place to film this, but this is the base that is was mounted into, and we are just going to start assembling this, or reassemble it is a more correct term, I think. Like so, and this should be threaded through here, like so. It's lots of screws to put this back together. You have this standoff here, we can start with that to center the board. And then it's just about putting this back together. These are the ones for the front panel. These are the ones for the drive caddy. These are the ones for the main board. And this is for the plastic cover. No, it was not. This is not for the plastic cover. This is for the LED. But actually this one, and this for the plastic cover was the same as this one, with only these nuts. Yeah, so we just start. So here they actually secured the joystick port, but not the keyboard ports with screws that goes into the metal chassis. This is really a well-built machine. It's lots and lots of screws, and all these screws that ties to the chassis is slightly too long, but of course they have chosen one size screw to make it less confusing and to be able to reach it through the connectors where it's possible. So they have to use quite longer screws than they really had to make the PCB just fit. That was the screws for securing the main board. This is the drive mechanism, and this is something you have to be really careful with, because these are slowly dying, every one of them, as far as I've heard, because this double-sided mechanism, they're not repairable. So if the head breaks, it's broken, and it's not easily replaceable, at least from what I've heard. I've not looked into that. As I've said earlier, I've only owned one 71 drive back in the day, and I don't have any much experience with it. I had this friend who had it, and we used it all the time for the Commodore 64 stuff, but that always worked, and I didn't look into it in detail. No, that should be good and secured. Here they have used threaded inserts. You can't see this, of course, but here they have used threaded inserts. So that's some really high quality stuff. This is what they should have done on the Commodore 64 back in the day. But I guess that the 64 was not designed in Germany. That's no guess, of course. I know that the 64 is designed in US of A, but if it had been designed in Germany from the scratch, maybe it would have had threaded inserts. This has been dismantled before, because I saw this screw was kind of scratched on the head, and they used sort of the wrong kind of screwdriver on it. This is of course the original power supply, and I'm just going to put it straight back in. I'm not going to do any capacitor stuff, but I'm going to measure with the scope the ripple of the 5 volt and 12 volt when I have put this back together. So maybe we have to order some parts for this. Just like so. Yeah, because these screws are from the side here. And these are all the rest of the screws for the 128D, and that is some mix here for the cover and for the power supply. And I know that someone has been making fans for these power supplies, but this is actually quite a big power supply. The main power supply for the 128, the normal version, only had a 2.5 amp power supply. This has a 4.5 amp. And of course the 12 volt should be derived from the 9 volt, and the 9 volt on the original power supply, I think it's 1 amp or something. So this is really overkill for the 128, because remember, this is for the 128 and the floppy drive. It's nothing else that should take more power, and also this version of the board takes less power than the original 128 because you have less memory chips. So not a huge deal, but of course there are some less power draw. Yeah, that should be the screws for the power supply. And then I just have the top cover to put back on. It should be this way around, like so. Yeah, maybe we should power it on before we start messing around with more. And then we need this power jack. Yeah, now the drive does as it should. I need to put this back in. This is a 3D printed. This here is a 3D printed lever for the drive. This should not be that hard to get hold of, I think, because I do think it's the same as the 1571, and there are some of them that has died, so it should probably be possible to get that. I will take the video and plug it in. I do have to make a risk assessment here, because I can plug in a disk and actually test this, but I need to make sure that the surface of the disk is okay, so I will need to go and find old floppy disk. Yeah, I will turn it off when I put on the keyboard, and we have not tested the keyboard much. I will see if I can make it fit in the camera view, but this keyboard did have some strange noises and some dust, so I'm not sure if it's fully working. We have tried some keys, of course, but let's see if we can zoom out on this in a way that makes us include part of the keyboard. And this is one of my, it's not a banana disk, but this is an Excel disk within a banana sleeve. And this actually was my Coiro writings from back in the day, written with a gold pen. And this disc looks to be in excellent condition. And let's just boot this machine into 64 mode. There are some terrible glare on this screen, but let's try to load the directory of this. Wow. It's working like so, but it was a bit stiff. Take quite some time, and it did make some noise, but yeah, it did. And let's try to list the directory. That was some this takes some time to get used to. And first file, income 1, that is a machine code file loaded into the right place. Remember, now there is no fast load, nothing on this machine. I have actually got a new capturing device for capturing this video, as my old one that I had since the Windows XP days, the Koenig one. That's here. I couldn't get it to work on this computer anymore, so I get a modern replacement, or it's about the same, I think, but maybe there are some driver issues and stuff. Yeah, version improved by 1001. Pressing this button will switch the counting of the health into stopping or decreasing. Yes. So that actually works, and that actually concludes my work on this 128. So we are going to end this this video here. I might keep this around for a couple of more days while I do find out, yeah, some issues with Tommy's machine. But the Tommy Arctic Retro 128, that will be next episode. So we have got 128 off our table, and we are starting afresh with Tommy's in the next episode. So thanks for watching. Hope you enjoyed the content, and I really would like to get some feedback on my videos. A lot of you comes with positive feedback and ask me to continue to make videos, but still I get very few people are watching my videos till the end. It's very short. If I make a 30-minute video, the average view time will be maybe 5 minutes. So please give me some tips what I can do to keep your attention for a longer time, because I do think I have interesting topics throughout the whole video, otherwise I do think I would have edited it out. But thanks for watching, see you again in my next episode.